This is lesson 2, function notation. So if you remember from lesson 1, we talked about a dog being on a post whenever his owner went in to get a drink. So here are the graphs of some situations that we saw yesterday. Each graph here is going to represent the distance of a dog from a post as a function of time since the owner left to purchase something from a store. Distance is measured in feet and time is measured in seconds. So something I forgot yesterday was for functions, it's important to note that when you have one input, there is only going to be one output. So if there are two, so if I put in a certain time and there are two different distances that the dog is, then that's not possible. That's not going to be a function. That dog can only be in one spot at once. Okay, so use the given graphs to answer these questions about each of the 3 days. How far away was the dog from the post 60 seconds after the owner left? So if we look at day 1, we're going to go over to 60 seconds and then go up and see that it's at this point right here. The dog was 4 feet from the post. So 4 feet. On day 2, we're going to do the same thing. We're going to look to 60 seconds and go up and see that the dog was 4 feet on day 2. And on day 3, we're going to do the same thing and find that at 60 seconds, the dog was 4 feet from the post. Okay. How far away was the dog from the post when the owner left? So when the owner left, that's going to be at 0 seconds. Okay. So we can see on all of these, the dog was at the same spot. If you remember from the information yesterday, those were our 2 points that we had. So the dog was 1.5 feet away from the post on every single one of these days. All right, the owner returned 160 seconds after he left. How far away was the dog from the post at that time? So now we're going to look at 160 seconds. And this is going to be something different than what we had yesterday because these graphs may be different than what we drew in class because I let you guys have a little bit of freedom with that. So we're going to say here, I would say that's approximately 3.75 feet away from the post on day 1. So we'll say 3.75 feet. On day 2 at 160 seconds, the dog was 4 feet. Remember on day 2, that was the day that the dog laid down. That's why we have that straight line. He didn't move after 60 seconds from the owner leaving. So that one is going to be 4 feet. Then day 3 at 160 seconds, we have, it looks like 0.5 feet. And if you guys remember this situation for day 3, the dog wound himself around the post. So if we have a post, let's say that the dog is attached to it with his 5-foot leash. And if he continues to run around the post in one direction, he's going to lose a lot of his leash because it's going to be wound up, right? So that's why it is 0.5 feet there. All right, the next one. How many seconds passed before the dog reached the farthest point it could reach from the post? So each one of these is different. We're going to look and see the farthest that the dog could reach was 5 feet. So we're going to look at our graphs, and this time we're going to look across to 5 feet and then identify the time.
Around 50 seconds.
So around 50 seconds for 5 feet. So 50 seconds. So on day 2, same thing. We're going to look across the 5 feet and then go down and see approximately how many seconds that was. And I think that looks at like it's about what?
39, 38.
I'd say probably closer to 35. Because, I mean, we could say 39, 38. I think somewhere between 35 and 39 is probably good. I'm going to go ahead and say 35 seconds because that point, I may be slightly off on my line there. It could be closer to over here. So I'm just going to say 35 on that one. All right, then our last one, look at that. The dog got to 5 feet really fast. What, do you guys remember what happened here on day 3? I believe the dog ran after its owner as the owner was walking into the store. So as soon as the owner turned to walk away, the dog ran the full length of what his leash could go. And then he wrapped himself around the post. So, let's see here. That's a really short amount of time. We could say anywhere from, let's say, 2 to 5 seconds. What do you guys want to put on that one? For day 3.
4 seconds.
4 seconds? Let's say 4 seconds. All right, let's go ahead and go to the next page. Okay, consider the statement. The dog was 2 feet away from the post after 80 seconds. Would you agree with the statement, or do you agree with the statement? So if I go back to this page, you don't have to flip back and forth if you don't want to. So it said the dog was 2 feet away from the post after 80 seconds. So if we look across to 2 feet and 80 seconds, is that true for day 1?
No.
No. What about day 2?
No.
What about day 3?
Yes.
Yes. So, do we agree with this statement? I think we could say we only agree with this statement for day 3 because it doesn't have a specific day on here. So we could say, I agree with this statement only for day 3. Okay. What was the distance of the dog from the post 100 seconds after the owner left? So this time, let's look at 100 seconds. What was the distance here?
For day 1, it was around 4.5 feet.
All right, so at 100 seconds, the dog was, so 100, comma, our coordinate here is going to be 100. It looks like about 2.25. So on day 1, 2.25 for day 1. For day 2, let's do that. Did the dog move after 60 seconds on that one?
No.
No, so what's our coordinate here? 4. So it is 104. And on the last day, and I'll flip back over there in a second, at 100 seconds, approximately how many feet from the post is he? Probably closer to 1.5 or 1.25. So we'll put 1.5. So we're going to have day 2 is 4 feet. And day 3 is, let's say 1.5 feet. All right. A handy notation. Let's name the functions that relate to the dog's distance from the post and the time since its owner left. function f for day 1, function g for day 2, and function h for day 3. The input of each function is time in seconds, so t. So use function notation to complete this table. So let's see here. Okay, so for day 1, we are using f for our function. So we're going to say f of 60 because we're doing 60 seconds. Okay? For day 2, we are going to say g because, let me change colors really quick. G is for day 2, so g of 60 seconds. Let me zoom in there. And then for day 3, we're going to do h. So it's going to be h of 60 seconds. So if we were to plug in the time, we would find the distance from the post for that function. So if we had an equation, we would plug in that number, and then we would get an answer. So let's go back and do day 1 for the distance from the post when the owner left. At what time was it when the owner left? Zero seconds. So we're going to say, so for day 1, we're going to say f of 0. What do you think we're going to put for day 2? G of 0. What about day 3? H of 0. Okay. What about C? We have the distance from the post 150 seconds after the owner left.
F of 4.5.
Why 4.5?
Because that was the feed. Oh wait, hold on.
What are we plugging in? What are we putting in our parentheses?
Distance.
No. The distance is what we get whenever we plug in the time. So the time is what's going in the center. So we're going to say 150 here. So what we're doing here is we're saying f of t. We're saying g of t and h of t. So what is going to be day 2 for C?
G of 150.
G of 150. And what about day 3?
H of 150.
H of 150. All right, describe what each expression represents in this context. So if we have f of 15, what does that mean? What represents the time?
The 15.
The 15. What if that is my input into the function? What will be my output? The distance from the post. So we can say F15. So the 15 is time in seconds since the owner left. And 15 is our input, right? So we can say, I should have done that in purple because that was our, let's see if I can change that. Oops, that is not what I wanted. I'm going to put it completely backwards. We'll just leave that in red. Okay, so let's see here. Let's say f of 15 is the distance from the post (15 seconds) after the owner left on day 1. Okay, what do you guys think B is going to be? We have G of 48. Yeah, 48 is the time in seconds since the owner left. What does the whole thing mean? The same for A? What do you mean by that? So if I said G of 48 is what? The distance from the post, 48 seconds after the owner left on day 2. All right, what about H of T? H of T is going to be, it's going to be basically the same thing, except for now we're going to have T for seconds, and then we're going to have day 3. So H of T is the distance from the post, T seconds after the owner left on day 3. All right, now we have the equation G of 120 equals 4 can be interpreted to mean on day 2, 120 seconds after the owner left, the dog was 4 feet from the post. What does each equation mean in this situation? So what day was H? Three. So we could say on day 3, how many seconds are we from the time that the owner left? 40. So we can say 40 seconds after the dog owner left. The dog was how far from the post? 4.6 feet from the post. All right, when you're ready, go ahead and go to the next page. All right, so we're going to do the same thing on B as we did on there. So we have F of T. What was F? What day was that? It was what? Day 1. So on day 1, okay, what is our time in seconds this time? T. So T seconds after the dog owner left, or the owner left. The dog was how many feet?
5.
Was 5 feet from the post. All All right, last one on this one. We have G of T. What was G?
Day two.
Day 2. So on day 2, what is our time?
T.
T seconds. After the owner. The dog was how many feet from the post?
D.
Was D feet from the post. All right, we have on 2.3, we have birthdays. Rule B takes a person name as it inputs and gives their birthday as an output. And on Rule P, takes the date as an input and gives a person with that birthday as an output. So, let's see here. I'm going to have you guys do this as groups in class today. Let's see here. There's only one page for this. So, if you're at home, go ahead and do this independently and let's do 2 of each. And let's see here. So let's see here. I'll do one really quick. So it says to complete each table with 3 or more examples of input-output pairs. If you use your name as the input to B, how many outputs are possible? So let's put Mrs. Rainey right here. Okay. And the output is going to be my birthday, which is January 25th. Are there any other possible outcomes for that one? No, I only have one birthday. So, let's see here. How many outputs are possible? Only one. Because people only have one birthday. Okay? If you use your birthday as the input to P, so let's say January 25th, how many outputs are possible? Could there be more than one output here? Yeah, there could be, because there are probably a lot of people that have the same birthday as me. Let me look here in Google. I'm putting this in my computer for those of you on the video. January 25th. Let's see here. Let's see here. A famous birthday that is January 25th is Alicia Keys. Let's put that. I hope you guys know who that is. You're going to make me feel old. Okay, so I want you guys to do the other 2. And let's see here. So on number 3, we're going to put, there are multiple possible outputs. Because more than one person can have the same birthday. Okay? Only one of the 2 relationships is a function. The other is not a function. Which one is which? So, is the rule B or the rule P going to be a function? Which one only has one possible output, B or P?
B.
B. Why B?
Because never mind, just one pair. Okay. Because only one. We only have one birthday.
Because we only have one birthday. So, let's see here. So, we'll say rule B is a function because there is only one possible output per input. For the relationship that is a function, write two input-output pairs from the table using function notation. So from the first one, we're going to write, so since it's rule B, we're going to use B for our function. So B of, I'm going to put Abe Lincoln, is February 12th. So what would the one for me be? What would the function and notation of that look like?
B of Miss Rainey.
B of Mrs. Rainey is January 25th. All right, make sure you do your practice problems on Canvas, and I will see you in class.